just reiterate that one, we thank you for your loyalty. We thank you for doing business with you. Particularly thank all our partners for their support over the years and helping us grow and become a better company. We appreciate all the technical support. And really what we want to do is we want to continue to earn your business. And part of earning your business is bringing new ideas and innovative solutions. And part of those solutions have got to be energy efficient. As you know, what's happening with our utility rates in North Carolina, and as a nation, they're going to continue to climb. So one of the things we want to do is take an earthwise approach to helping you manage your buildings, both new and old. And if you think about it, North Carolina was really air conditioned in the 60s, 70s, and 80s. And it's hard to believe, but the 80s were some 20, 30 years ago. And so with that, there is a real energy story in renovating old facilities. Not to mention the fact that with integration and technology, we can bring lots of opportunities to more efficiently manage those buildings, both during the construction phase of planning and also ultimately the service phase of taking care of that facility, because it doesn't do any good to put these sophisticated systems in and not take care of them. So with that, again, thank you very much, and thank you for spending some time with us. I just wanted to mention that. We really appreciate it. I want to introduce a friend of ours, Mark McCracken. Mark is the CEO of Calmac Manufacturing. Calmac is a partner of ours, but it's the largest manufacturer of thermal energy storage equipment in the world, with over 3,700 installations in 35 countries. So they've got quite a big scope. In his over 30 years with the firm, Mark has been involved in all aspects of the company, including R&D, contracts, patents, manufacturing, marketing, and finance. He was the principal investor on research projects with Oak Ridge National Labs, NASA, and National Renewable Energy Resource Lab. In his continuous support of energy efficiency, he is regularly in contact with the Department of Energy, EPA, EPRI, and electric utilities across the country and around the world. Mark has a BS in mechanical engineering. He holds 3 U.S. patents and is a licensed professional engineer in the state of New Jersey and a lead accredited professional. He is currently or presently past served on as a past chair of U.S. GBC. He's a recipient of the AEE Energy Engineer of the Year Award, AHRI Board of Directors and Thermal Storage Product Selection Chairman. He's a distinguished lecturer at ASHRAE. He's chairman of ASHRAE's Thermal Storage Technical Committee and member of the Alliance to Save Energy. He's also a member of the Electrical Storage Association and vice chair of the ASHRAE Standards Committee 189.1. Please take a moment and welcome Mark to our seminar.
It's a pleasure to be here. As I said, I'm CEO of Calmac and a good friend of Brady Trains. They have been our representative probably for 25 years and have done a hell of a job for us over the years. When Randy invited me to speak, he gave me a very broad range. He said, you know, please talk about energy and sustainability and maybe some of your USGBC experience and fracking and gas and coal and this sort of stuff. So he gave me a huge range. So I'm going to be covering a lot of different things. I might hit a couple of political third rails, you know, but it doesn't matter because I'm not running for anything. And essentially I will just reflect on the experience of the last 30 years. I recently saw a marketing guy give a presentation, and he said you really have to lead with your values to give your message a chance for people to know, you know, more personally about who you are. So I gave a talk for USGBC, and they said, okay, we're going to ask, you know, some certain questions. So I'll give you just a little bit of my history. Married, grew up in New Jersey, right outside of New York City. Basically born and bred there, went away to college at University of Rhode Island, came back to New Jersey, started working for my father in 1976 after college. Lived there for Jersey a long time, and then I moved into New York City, where I live now, chasing my then girlfriend and wife of 20 years. Favorite where to spend my time? I like being outdoors. I like a lot of sports, almost all sports. I was a pole vaulter in high school and college. I just climbed the Matterhorn with my son in Switzerland this past summer, which was quite a challenge. Favorite fictional character? MacGyver. I mean, if MacGyver's not, you know, he's just like the essence of who I would like to be. He could solve any problem and get out of anything. Best advice I ever got, and this is incredibly appropriate for where I am right now, was from my track coach in college. He said, "Mark, if you want to be a happy man, marry yourself a Southern girl." Which I did. Birmingham, Alabama, Auburn girl, and she's truly spectacular. Your motto, you know, what words do you kind of live by? And I think I got this really from my family and my history. You can make a positive difference in the world. My great-grandfather was the chancellor of NYU, you know, a big major university in New York City. And, you know, he invented what's called the Hall of Famous Americans. It was the first Hall of Famous people, and actually that's what he coined the term Hall of Fame. That's where the term came from. He also, it was his idea after speaking to Theodore Roosevelt. Theodore Roosevelt called him up and said, you know, we're having too many accidents playing football. I'll ask you a question. How many people do you think died playing college football in 1907? The answer is 28. 28. So Teddy Roosevelt called up my great-grandfather and said, you know, we got to put an end to this. And so my great-grandfather and a couple of other chancellors came up with the idea, and they created the NCAA. His son, my grandfather, was president of Vassar College for 30 years. Vassar, as you may know, is a women's college, a liberal women's college, and he did tremendous amount for women's rights throughout the years. My father was, besides being national champ in squash 11 times and nationally ranked in tennis, he was an inventor. He designed a combustion chamber at General Electric Company and throttled the first jet engine ever built. And then he left General Electric and went on to start Calmac. So the invention you would all know is the hot dog machine in the ballparks. You know, the pipes, you've got the pipes and the hot dogs are rolling around the quarter. That was one of his inventions so many years ago. The point is that these people had impacts, okay, and you can also have impacts. I didn't mention my brother. My brother's one of the top scientists in the world on climate change. I know this is a hot topic out there, and so I'm just going to ask a question, and literally everybody is going to need to answer the question. There's going to be 3 choices. How many people out there believe that humans are having an impact on our climate? How many people don't believe that humans are having the impact on our climate? How many people don't know, they just aren't sure, they can't tell from what's being said? Okay. Climate change is a really, really important issue. And I can understand why people have problems figuring it out, because climate change is as complicated as brain surgery. Now, I'm quite impressed with the number of people here that believe we are having an impact. Across the United States, it's about 50% out there. It's, you know, people just don't seem to believe. But the reality is it's hard, because they put a guy on the TV screen, they put 2 people, they split it in half, and one guy says, oh, it's absolutely true, it's a given or whatever, and the other guy says, no, it's not, and it's only 50-50 on the screen. But you can't tell that there's 2,700 scientists behind the guy on the right saying that, yeah, this is real and it's actually true. So, versus the 1 or 2 that are on the other side. Climate change is a very big issue. This particular picture that you see here, this was the first time that we had visual proof and you had a picture of the entire globe. It was taken in 1968 when the astronauts went around the backside of the moon. And you could see that this Earth that we have is this beautiful big floating ball out in this endless space. We didn't always know that it was a ball. Plato and Aristotle, basically back in 400 BC, were saying that they felt the Earth was round. Copernicus was the one who figured out that the Earth was not the center of the universe. However, there was a big force, and namely it was the church was saying, no, it's absolutely flat and the Earth is the center. And it was only until Magellan really sailed around the world that we really proved without a shadow of a doubt that the Earth was round. Let's look at smoking, and I know I'm in an area that this may have not been the best choice of topics to bring up. But back when I was growing up, in the 50s, this is the advertisement that was out there. These are the advertisements that were out there. And I was speaking to an architect friend of mine who's a little bit older than I am, and he grew up down here. And he was put on his grandmother's knee, and his grandmother said to him, Randy, he's 8 years old, he said, there's only one thing you have to do for me to make me proud of you. I'll be proud of you for the rest of your life. One thing. And he was like, wow, what is this one thing? And she said, don't smoke. So this was a not well-educated, higher education, this sort of thing. Never went to college, barely went through school. And yet she knew intuitively that this was an issue. Today, you go into duty-free, and this is what you see on the cartons of cigarettes. Okay? And it took a long time to kind of get to this type of thing. Now, I'm not saying smoking is bad or good, but this is honesty. This is being out there, and people can make the choices on what they want to do because it's a free society. But the honesty is out there. If we look to asbestos, asbestos is something that probably had an impact on a lot of different families. The first claim for asbestos, fatality claim, was in 1925, all right? Now back in the 40s, your fathers, maybe some of you, but your father's fathers, we were building ships and sending people off to war, and asbestos was all over. My father was working at General Electric Company. Asbestos was all over the place, and there were no warnings. But 20 years earlier, they knew all about what the issues were associated with these things. So here we are today with climate change. Climate change is a big, big deal, and it's real, and it's happening. And one of the things about climate change and CO2 is that there's a huge time delay between when you put it up into the air and when it has its major impacts. It's got about a 100-year half-life that this stuff's sitting up there. So it's kind of like when we had those first supercharged cars, you press on the accelerator, there'd be this delay, and then all of a sudden you'd take off. It's the same sort of thing that we've gotten with putting carbon up into the air. Now, there's nothing wrong with carbon, right? Carbon's a great material. We're 80% carbon, okay? But putting it up into the atmosphere is something that's going to be a big, big problem. I asked my brother, how bad is it? How bad is it? What do we have, how fast do we have to turn around? And he said, well, we're basically heading down a highway going about 70 miles an hour in the wrong direction. We may have just passed the polar bear exit, I don't know. But we've got to slow down as fast as we can without killing ourselves and turn around and go in the right direction. So we are going to have to adapt to the changes that are going to be coming no matter what we do, and we're going to have to change what we're doing in order to lessen the impacts. When he talks to me about climate change, and we'll get on to another topic in a second, but when he talks to me about climate change, I say, put it in easier words. Put it in easier words. So he used to say if you had a pot of boiling water and it's on medium, they talk about weather events. Think of each bubble coming up in that pot of water as a big weather event, because that's what weather events are. They're big and energy-intensive things. If you turn the heat up you can't point at any particular bubble and say, oh, that's because I turned the heat up. You just know that there's going to be more bubbles. The better example I've just heard recently, I think this really hits it on the nose, is Barry Bonds and steroids. Steroids are, or CO2, are steroids for the environment. If you look at Barry Bonds, you can't point to any home run that he hit individually, but you can tell that his performance was greatly enhanced and intensified because of what he was taking. So that's the same sort of thing that is happening with CO2. There's a couple other quick analogies. One is, so now you take pasta and you throw pasta in the water, right? What some of the naysayers on climate change talk about is they want more information, more specifics, more data. And that's like trying to ask exactly how one particular noodle in that pot of boiling water gets cooked. And you can't do that. Just like if I took a piece of paper and I dropped it on the floor, there's no way to tell exactly how it would line up and fall on the floor. Okay, it'll be within a certain range, but you can't tell exactly. And with the pasta, they can't tell you either. But what they can definitively tell you is that pasta will be cooked in 9 minutes. Okay? So the final thing is, I think the climate change people named it wrong. You know, first it was global warming, and then there was some cooling effects and this sort of stuff that happened temporarily. Climate change, people think it's always changing, right? And it has. It has been changing. Spoke to an HVAC engineer recently, and he was saying, "Oh well, it's a bunch of bull." He said there's evidence that there's wood underneath the ice plates in Greenland. And you know what amazes me about that is, you know, number one, I really don't care what an HVAC engineer has to say about climate change if he's not an expert on the topic, just like I wouldn't care about what he thought about brain surgery. But it amazes me that, you know, he finds this factoid and that's what he's locking into, right? And he doesn't think that people that have studied this or the real experts have not found that particular piece of information also. All of that has been explained. Reality is the Earth's been a lot hotter than it is now, and it's been a lot colder. And CO2 has been a lot higher, and it's been a lot lower. The problem is that CO2 has changed gradually. And now it's not. It's happening extremely fast. And so they named it. They named it wrong. It's really climate destabilization or climate disruption. We've been in, for our species, a very long period of a stable climate where we have been able to flourish and grow in a big way. And now we are rapidly changing that. So what are we going to do about it, right? This is all very depressing, isn't it? It's very depressing. But it actually isn't, because there's lots of things that we can do about it. We can change what we're doing. We can change what we're doing, and our actions will have impacts on the future. Oops. So this is a Chevy Bolt. Calmac, my company, bought a Chevy Bolt. It was number 453 off the line. And I got to tell you, this is a spectacular car. It's absolutely a spectacular car. My vice president is one who drives it every day, puts 12,000 miles a year on it, getting over 250 miles per gallon. Plus, it doesn't go any higher than that. Now, they don't calculate the electricity, and we'll get into electricity in a minute. But you know, you see some of the ads that, you know, people forget where their gas tank, you know, filling spot is. The most amazing thing happened earlier this month. When we bought the car, it said you must use a tank of gas every year because gas gets stale. And I was like, well, that's funny. That's funny. And in the first year, he filled up 5 times. 5 times. And he had a kid in college, and so he was doing, you know, a couple 100-mile drives and this sort of stuff, right? But his commute from work, it's less than 25 miles back and forth. So it's all electricity. So he came into my office on a week ago, and he said, "Mark, you're not going to believe this." He goes, "Friday, the car, when I started it up, it said to me, it's been a year, almost a year, since you filled up your tank. Can I run engine?" And so he presses no, right? He wants to go the full year, right, and push it as far as he can. That Monday morning, he goes in, he starts the car up, and the engine comes on. Doesn't ask him anything. He does everything he can to try to turn the engine off, right? And obviously, the car is programmed that if you truly go a year, it is going to force you to use your gas to make you put in the new fresh fuel, okay? So the car is extremely advanced. It has a guidance system, which is absolutely amazing. The first time I was driving, I didn't have the guidance system on. I was just driving this car. And I live in New York City, and I drive into New York City, and I'm going down the West Side Highway, listening to the music and this sort of thing, and all of a sudden the music goes down. And the car says to me, traffic in 1 mile, lasting for 4/10 of a mile. And then the music goes right back up, and I'm listening to the music. And I hit the traffic right at the Triborough Bridge, and it was 4/10 of, I mean, it was the most stunningly, incredibly impressive piece of technology I've ever seen, while it was just running on electricity. So we're going to start changing how we do things. How does this car work so well? Well, basically, it's got an engine, but it recovers a lot of the braking power. So it's regenerative braking. It puts it back in a battery. It's got energy storage, which I'll talk about in a minute. And then it's using its power off the grid. So it's balancing engines and motors and energy storage in order to make this huge leap in technology. By the way, on just gasoline alone, the car gets 40 miles to the gallon. So it's a pretty impressive machine. Well, now let's start talking about the impacts of energy and the grid. This is kind of a representation of the way the grid used to work. Basically, we have fossil fuels. Is this a pointer? We have fossil fuels in the lower right-hand corner, more coal than gas. We've got hydro and nuclear, and all that power gets put into the grid, and then it just goes out and gets used. And that's all an instantaneous process. It happens immediately. It always has to be balanced one to the other. The electric grid in the United States is broken up into 9 different regions, New England being one of those regions. And so this is a 1 week of cycling in New England. And you can see it peaks at 28,000, but earlier that day it's only at 17,000 megawatt hours. So all this energy that we have in the grid needs to be energy that is available and can give us that power, and we have to build the grid to be able to meet these instantaneous loads. This is what's called a duration curve. A duration curve takes all the hours of a year, so there's 8,760 hours in a year, and they stack the lowest output hour on the far right-hand side and the highest on the far left-hand side, and they stack them up as they go gradually get greater. So the lowest output of the year is 9,000 megawatt hours from this utility, and the highest is 28,000. Now the interesting part is that the last 21% of energy usage, or peak power draw, is used for less than 2% of the time. So we're building this tremendously huge system to generate this stuff all instantaneously for a very, very short period of time, which is very inefficient and extremely expensive to do. Well, because of the pressures of climate destabilization, we're trying to reduce the amount of carbon that's going to be used in our electric grid and clean up the electric grid. So we're starting to add wind, the upper right, and solar, to these things to start reducing some of the carbon impacts. We're increasing the natural gas to a certain degree right now. But those are having other impacts on our grid. This is a wind farm in California. It's got 1,000 megawatts peak output. This is about 9 days worth of diurnal cycling up and down. The problem is those red diamonds that you see are marking when the utility was hitting its peak. So when the utility needs the electricity the most, the stuff that they're putting onto the grid is giving the least. Right? Now, this is not unique to just California. I have a drawing, I don't think I didn't put it on here. 7 of the 9 electric grids, this is the way wind is. They've got a lot of capacity installed, but it's not blowing where they need it. So this is a big issue. Well, what's this issue doing? Everybody knows that electric rates, or I hope they know, because I sell a product that takes advantage of it. Electric rates at night are a lot less expensive than they are during the day commercially, okay? And that's because there's a lot less SX generating capacity available. There's all sorts of reasons for it, but it's dramatically less expensive for your electricity at night, somewhere in the 50 to 60% range during the summertime. Well, adding wind is having an impact that's even amplifying that effect. So in Texas, in 2009, 11% of the hours, the wholesale price of electricity was 0 or less than 0. Okay, so what's less than 0 on an electric rate? They're paying you for the power. Take the power, please. The more you take, the more we'll rebate you. Okay, so that's 11% of the hour. So the wind is blowing at night, it's putting this stuff on the grid, and they have nowhere for it to go. And that's because the grid does not have any storage on it. It's probably the only thing I can think of that doesn't have storage. I mean, you all have, almost everything we create has energy storage built into it. You know, the car, the fuel tank, your cell phone in your pocket, everything's got storage built into it. Heck, we do. We have our stomachs. We eat now and we're good for 4 hours, 5 hours, okay? So storage is naturally built into things, and yet there's no storage on the grid. So where's the problem here? The problem is this. What are these? They're examples of stored energy, okay? And what we're trying to replace it with is wind, which is something moving, and solar, which is something hot, okay? So that's real energy. So the question is, if you're replacing stored energy with energy, where's the storage? And that's the problem for the grid right now. There is really no storage, energy storage, on the electric grid. And so these new resources that we're adding are not as valuable as they really could be. So the new grid is going to be a smart grid. And the smart grid is going to need other tools. The smart grid is defined lots of different ways, but basically you can think of the smart grid as two-way communications between the buyer and the seller, and everything in between that goes along with that process of buying and selling it. But what's really going to help out the smart grid dramatically is energy storage, because now you won't have to oversize the grid as much as you do and spend a lot of money on that. And you're going to be putting energy storage at the building so that you can store nighttime power cheaply and also store it on the grid so you can run fans and pumps. And we will be changing to a lot more natural gas. I talked about gas and coal and fracking. The problems coal is having right now, with the decrease in coal, they're all up in arms and this sort of stuff. Not a lot of it's coming from the EPA. Some of it's coming from the EPA, but most of it is competition with the natural gas that's available now through fracking. Okay, it's definitely putting the pressure on both on price and on environmental range. So this is what the grid is going to look like, and designing buildings to be able to take care of and use this energy is important. One last thing on energy, stable electric rates. So who here thinks their electric rates are stable? Okay, electric rates go up. Now they haven't varied as much as other forms of energy. Natural gas was up at 14, now it's down at 2. Gasoline goes all over the place. The Edison Electric Institute did a study, and there's one form of energy that has not changed, and actually it's gone down in price in the last 30 to 40 years. The answer to that is off-peak electricity. So if you separate the cost of on and off-peak electricity, okay, the baseload nighttime electricity has stayed the same. So I don't know anybody that is designing buildings to be around a year, okay? So why would you look at the electric rates or the rates of energy like today? You have to look over the future. And people are building buildings for 30, 40, 50, 100 years. And so as designers and engineers, you really want to look at whatever can take advantage of off-peak rates, and energy storage can do that in a big way. I mentioned I'd touch on fracking and coal. Fracking, I think is going to be it's going to be a very useful technology for us. However, I think we're also going to have to seriously look into how to regulate it in a way that we know that when we're going down beneath these aquifers that are supplying cities like New York and all the major cities around the country, that the fracking isn't going to have some sort of problem that's going to cause an issue. But it can be done. I think technically it's being done now, and we just have to watch it. We have to make sure we have that oversight in place. Coal, I heard a professor speak, and it was very interesting hearing Mr. Wallen speak this morning on the economics. I heard a professor speak on coal. And there are ways now to take energy out of coal, pure, clean hydrogen energy out of coal, okay? And you can get 20% of the energy out of it absolutely clean. And what you have left over is almost a pure carbon. And that pure carbon can be used as a brick, as a construction material. It is harder than bricks, it lasts longer than bricks, it's lighter than bricks, okay? He had a sample of the stuff that was absolutely amazing. And oh, by the way, it doesn't have to be the black color of coal, it can be any color you want it to. So repurposing what some of these raw materials can do for us as a society may be a very big solution to all the impacts that you may have on the coal mining industry. So we talked about the creation of the energy, we talked about the climate and why we have to do it. So what are the biggest drivers? Well, the number 3 biggest CO2 driver is industry. Transportation is number 2, and buildings is number 1. Buildings is number 1 impact on CO2. And that's kind of what drove my involvement with the USGBC. I was on the board of directors for 7 years. It's a terrific organization. Its mission, it's kind of hard to read, but it's basically to transform the way buildings and communities are designed, built, and operated, enabling an environmentally friendly and socially responsible, healthy, and prosperous environment that improves the quality of life. That's a nonprofit's vision for the future, right? This is their mission, okay? And so it's really hard to argue with trying to, make the world a better and safer place. I put the guiding principles of USGBC up there because, I think everybody knows about, I've heard of USGBC now, they've heard of LEED, certainly, if you're in the building industry. I'll only touch on the first guiding principle. Promote the triple bottom line. What's the triple bottom line? Triple bottom line is you have to balance environmental, social, and economic impacts, okay? This organization realizes that if it doesn't make economic sense, it's not going to work, okay? And you have to balance those impacts, but it's looking at all 3 of them, not just the dollars. You have to look at the social and the environmental impacts. The other ones I won't go over to, but it's an organization based on some terrific principles. It's an organization that has grown dramatically. It's got almost 13,000 members now. Got 77 chapters across the country with 30,000 individual members. There are 195,000 lead APs right now out there around the world. That's a big number. 182,000 projects. Now that's including homes, but the commercial, there's probably about 40,000 projects. This number blows my mind. 2.8 billion square feet has been certified. So that's not the people waiting in line, and trying and going through the process. 2.8 billion square feet have been certified. Now, a lot of people have issues with LEED. Okay, oh, it's a pain, you got paperwork, you got all this sort of stuff. I would say the people volunteered to do it, work real hard. All these people have good intentions. We maybe see different ways to do it. But 2.8 billion square feet actually doing it, That's a lot of people trying to do the right thing, learning about doing the right thing, making mistakes on how they did it, and improving the next time they do it. That is a lot of square footage. And oh, by the way, there's another $8 billion in the pipeline behind it in order to keep this going. So a whole construction industry, all right, the building of buildings is this gigantic ship that we're trying to move in another direction. 1.5 million square feet every day. That's a New York City skyscraper that is being built every single day, that is being built green. Green Build, it's a great show. If you haven't been to it, it was in San Francisco this past year. Almost 5,000 people came to that. Schools. Schools is a very important place for us to be designing green buildings and having kids in schools. One of our goals is to get every child in a green school within a generation. Okay? I was talking to somebody earlier, and we were talking about our children, and some people think that this is a conspiracy to teach the children about this stuff. And I really look at green buildings and education of children is getting back to the past. I don't know, if you've ever tried to explain sustainability to somebody, one of your elders, my father or maybe my grandfather or whatever, if I was trying to explain sustainability to somebody, and they got this funny look on their face. They were about 80, 85, they got this look on their face. And I realized that this is the way they lived most of their life. They used the same plates, they used the same silverware that had been passed down. They only had, one TV, they got the wood from locally, and they, built their houses. I mean, we're getting back to the future, and yet the kids in our generation now, these ones that are in the schools now, they have no clue. They have no clue. They don't know where their food is grown. They don't know how food is grown. And so this is a matter of education. It's like you can't just keep consuming. We have to, get those things getting recycled and reused. So higher education is a big one. Federal projects. I brought up some of the stuff having to do with the asbestos because the new version of LEED, which I'll get into, the big change is that we want the companies to say what they're making their products out of, disclose. It's not, we're not saying, hey, you can't use them, you can't use a product. All we want you to do is disclose what's in them. Well, American Chemical Council is going crazy about this. They don't like this, all right? The old asbestos companies are still in there, right, okay? And it's the same type of issue. Now, I don't know about you, but I think you would probably want to know about the flame retardants that are under your newborn baby's head, which is just constant in every foam pillow that's out there, okay? You should be able to make choices about that and be informed. So we're being fought right now in the government right now, and they're trying to say ban LEED from all federal governments, ban LEED from it. And there's a huge lobbying effort by the chemical companies that we're having to deal with in order not to have that happen. We've had huge impacts on government buildings and will be continued to do so. LEED for homes has really taken off. We've got 33,000 LEED certified homes. So we're really trying to make sure that it's available because home construction is about to come back in a very big way. LEED for existing buildings. 80% of the buildings that are going to be around in 2030, they're already here. So I think I'm speaking to a lot of experts on buildings and existing buildings, and all the products that you have in the next room that you're learning about, those are giving you the tools to deal with these things. I was fortunate to go to Taiwan to visit, at the time it had just turned the second tallest building in the world, and they did LEED EB on this building, LEED Platinum. Okay, this was quite amazing. What was so amazing about it, has anybody here done LEED in a building? Okay, anybody done LEED EB? Existing buildings? Okay, so, yep, one back here, okay. Can you imagine having 80 different tenants in a building that had to agree to do what is in LEED? 80 different tenants. It's tough enough with one company to get the resolve in order to go forward with it. This guy had 80 different companies and did a 2.2 million square foot building to LEED Platinum. It was truly, truly amazing. There's USGBCs are growing up all over the world. There's 28 member countries in the World Green Building Council, and there is huge impacts starting to develop. And why is it? Why is this all so important? Well, we have to reduce our CO2. Buildings are the key. 50% of the world's population are in cities now. 50%. It's only 2% of the land mass are in the cities, but 50% of the people. 2/3 of the CO2 and 2/3 of the energy use is being consumed within the cities. The cities make up for 80% of the world's resources that are being mined. Okay? 1 billion tons of waste that's just going to the landfills now per year, right now, going out of the cities. So by far, the biggest opportunity to change is addressing buildings in the cities. So when we go, in our job, we get review, we get a performance review. If you go to the stock market, they've got charts. If you're in sports, they've got stopwatches to see how fast or how high you go, right? But buildings, we really haven't measured our buildings well. We pay the bill, and that's all we do. And LEED is about measuring the performance of these buildings. You all know it's a rating system for measuring the performance of these buildings. We came up with LEED as a way to shift the marketplace. If you break the marketplace into the innovators and the risk takers on the far right-hand side, that's really what LEED was all created for. It was to help people design better buildings and take us in that direction. And obviously, it will draw the rest of the marketplace in that direction. With LEED, the original creation, we had points. Points didn't make a whole lot of sense. We kind of divided them up. If I hear one more comment about the bike rack point that, from people, I was about to shoot myself as chair. But I mean, yes, they did not do a good job on dividing up the value of the different points. In 2009, we made a big change, and we started apportioning the points based on what actual impacts they were having. So you could see climate change is a big one. Indoor environmental quality, absolutely a very big one right now, and it works its way down through resource depletion, human health care, this sort of thing. So we fine-tuned LEED. We are moving the marketplace. If I had a pointer here, I could point a little bit better, but basically, you've got the traditional building codes here. And we started off with LEED, with certified silver, gold, and platinum. And as time is presented, we're slowly shifting LEED higher and staying ahead of, certainly above the codes. Now, I was the vice chair of Standard 189, was the first standard for a green building. So LEED is a rating system. It's voluntary. It's like take one from column A, one from column B, you total it up, and if you get points this high, we're going to rate you as this good, okay? A standard is totally different. A standard written in code language is something you shall do this, you shall not do that, okay? So Standard 189 was trying to take LEED and put it into something that would actually be code, right? And so we finished that about 3 years ago. It's also progressing out. So this is, 189 right here. And right now, actually, we've moved into here. As you heard the earlier speaker at 10 o'clock, your new NC energy code, right? It took a 30% jump in 1 year, right? Well, LEED was, ahead of code, but all of a sudden code has jumped up dramatically. So the code is almost interfering with the certified level of LEED right now, okay? So we're going to keep moving LEED up, but the codes took a really big jump, and we don't want to, jump another 30%. That would be almost impossible for buildings to do. So we're going to, continue to move it up, but not as fast as we have done in the past. Performance is going to be the main focus of the new LEED. We got a lot of grief. It's like, oh, you're designing buildings and you do good design, but how do you know how the buildings operate? Well, that wasn't really true. I mean, it was true in some cases, but all EB buildings, existing buildings, have always been based on actual energy performance. They're based on the Energy Star rating, and that's all based on actual energy use in the buildings. But in the new construction, we're going to be focusing more on the actual performance of the building. So for instance, instead of using non-emitting materials, well, you'll get maybe a point for that, but if you test the environmental quality inside the space, you'll get more credit for that, because that's the actual performance of what you did on the construction of the building. The same way with energy and water. Building Performance Partnership is a partnership with about 200 different member companies, USGBC, ones that have a lot of buildings in the portfolio. We created a partnership with them. We are trying to establish a green building performance database with all these buildings and learn more information. We're trying to find and bridge the gap between design and construction and operation. And then we're trying to figure out performance of people in buildings versus how green the buildings are. Because if you can increase the performance of people in buildings, that's a gigantic multiplier. That's 10 times the value of the energy that you're saving within the building. If you're part of this group, you get a report. The report, shows you trends over time. It shows your particular year. It shows your energy. It shows your water performance. And so this information is now being collected. We are assembling all this information on buildings. All this information in buildings on what we call GBIG. GBIG is a Green Building Information Gateway. Oh, thank you very much. Thank you. Yep, thanks. Green Building Information Gateway. All the buildings out there that are LEED, all the buildings that are Energy Star, all have been put together into this gateway. We are collecting, breaking it down into categories. We've got the activities of the building, so the certificates got like Energy Star or whatever, disclosures. We've got the list of buildings. We've got the places where they are, so we can pull them together and sort things. We've got the strategies they used in the building. What do they do in this building versus this building? What are the things that are people doing? And then the collections. So all this information is now available. You go to gbig.org. It's all free. You can sort the buildings. You can see it. There's a tremendous amount of data in here, and you can see what people are actually doing in there. You look at the USGBC headquarters, which is a LEED Platinum building that we did for commercial interiors. It is there. You can see it got a Platinum rating, excellent rating. You can look at the energy. You can look at materials, water, indoor environmental quality, all the different things that it did. This is the general, which compares it against other buildings in the rating system. You can look at the energy usage and the specific things that they did on energy and how they got their points, and you can do this through all the different categories. But it's not just for this building. They're on L Street in Washington. You can see that there's 30 different buildings within the Washington area, all that type of building. You can see this particular building, what else happened in this building. So this is a timeline of the building itself. So there were people in it before that were doing energy things. You can look at the District of Columbia. You can cut and slice and dice the information any way you'd like. Or you can kind of cut it right across the country, and let's look at the climate zones and what people are doing in similar climate zones in these green buildings and how it compares to yours, and drill down as deep as you want. So I've covered a lot of different things. I've covered climate change. It's a big deal. I've covered energy, and I've covered how we're trying to address these things. And I'll close with a couple things. To put it in perspective, I always like to try to use an analogy. And I heard this one, and it blew my mind. So people at rest, humans at rest, like you are right now, you are burning 150 watts of energy. So think of a 150 watt light bulb running. That's what you burn as a human being sitting here right now. If you were a hunter-gatherer and you were going out, killing your food, supplying what you need to exist, you would be consuming 250 watts. Okay? As Americans right now, sitting here, we are each consuming 11,000 watts on average. 11,000 watts. So 11 kilowatts of energy, 24/7, 365. Do you know what mammal out on the planet living today consumes 11,000 watts? I'll take a guess. Come on. No. Another guess.
A whale.
Whale. The great blue whale. Great blue whale. So the great blue whale population topped out at 350,000 approximately. 350,000. We have 360 million people in just the U.S. So nature kind of capped out this great blue whale at 360,000. We have 1,000 times more of that consumption going on right now with our population. And oh, by the way, there's another 7 billion people out there, and that number is kind of going up. So I don't think the ocean could have handled 360 million great blue whales, and it's definitely not going to handle 7 billion great blue whales out there. Okay, so I think it puts it in perspective on what this planet can do for us, and we got to change how we're doing it. There are solutions to what we're doing, and we can do a lot dramatically better than we're doing with the resources that we have available to us today. And so I'll close with a cartoon, which I don't know, I kind of think is funny. I'm not sure if you can read it. It says, so these scientists did this experiment. You drop a frog in boiling water, it jumps out. Guy says, but if you put him in warm water and heat it slowly, he just swims around until he's cooked. Guy says, what's the point of that experiment? Guy says, beats me. Science, go figure. Must be one of those global warming studies, right? We got to watch out. We have serious issues to deal with here. We've got serious issues to deal with here, but they are solvable. We can solve them. We absolutely can solve them. And it's all a matter, it's about the kids. It's about the kids that are out there. It's your children. I was at a board meeting, and we were talking about the goals of USGBC. We had a guy from healthcare, and we had a guy from the insurance industry, and then I was in the group. And one of the goals had material resources and healthcare and climate change all in the same goal. And the healthcare guy said, you know what? We should break those out into different goals, because healthcare is something that people identify with immediately. You know, their health, internal environmental air quality, in offices, they get that. That's immediate, that's personal. Whereas climate change, that's like in the future, right? And it's this mushy thing that you can kind of put off. Health, it's different. He said, let's break it up. And the insurance guy, and I said, yeah, you're right, we should break it up. And the insurance guy said, yeah, we should break it up. He goes, but you're wrong. And this was 3 weeks before Sandy. He said, you're wrong. Climate change is affecting us now. Our claims have doubled each decade for the last 2 decades. It's ramping up like a hockey stick, okay? So these impacts are hitting us now. So it's going to be a matter of your children. We're going to see it. It's not going to be as huge as it is going to be for our children. And so someday, maybe 30 years from now, your grandchild may ask you a question, and they're going to ask you, what were you thinking? What were you thinking? And your answer is probably going to be one of 2 things. It's going to be, well, scientists were saying this stuff, but, you know, other people were saying other things, and, well, maybe I saw some things that might have been related to, but I just didn't do anything. Right? Or your answer is going to be, you know what, we saw the scientists out there, and we changed what we were doing, and we made a huge difference, and, you know, we're very proud of what we're doing. That's basically the answers you've got to have. And I know this group because most of you people, I was expecting the other ratio of non-believers to believers, okay? Most of you people believe, and that's why you're here to learn about how we can do this. And so with that, I thank you for your time. Appreciate it. Take any questions you have. Thank you. Yes, sir, in the back.
So I know your involvement of ice storage or shipping, so I don't see how that produces overall CO2 output into that. Or maybe you could address that and correlate that with maybe some other strategies that are most CO2 better.
Sure. So the question was, he knows I do, our company does thermal storage, ice storage in particular, and he doesn't see how that relates to a reduction in CO2. It's, first answer is, in the booth there's an article, The Myths of Thermal Storage, and that can address part of what you're talking about. To relate it to energy storage in general, that wind blowing at night, okay, it is dramatically more energy efficient. We need to store that energy somehow, okay? We can store it in batteries. Part of my prezo, and maybe Mark Johnson spoke about it in the other place. There's different ways to store energy. You've got the lithium-ion batteries in your pocket, lead-acid batteries. There's what's called pumped hydro for shifting a lot of energy. You take water and you pump it up a mountain, and then during the day you take that energy and you run it back through the pump, and now that pump becomes a generator, and you get the electricity back. Okay, so that's another way, a major way to store a lot of energy. The problem with that is that it's only 65% what's called cycle efficient. Okay, so you put a megawatt hour of electricity into the pump to pump the water up to the mountain, and by the time it comes back down and you get the electricity back, you're only getting 65% of it back. As opposed to that, you can take that energy at night, store it at the building, okay? The line losses are less, the transmission distribution lines losses are less. You could run it at the building and store that energy. So if you have this wind energy, you could use that wind energy to pump water up a mountain, but it's dramatically less expensive and more energy efficient to run it to the building and store it at the building, okay? So you could use carbon-free wind, store it, and you're air conditioning the building with carbon-free energy, okay? That's one way to do it. Then there's a lot of different things when you're shifting from on-peak energy to off-peak energy. The heat rate of power plants, heat rates are what is how many BTUs you burn per kWh created and delivered to the building. And the heat rate of baseload plants are much better than peaking plants are, okay? And so for the same kilowatt hour that goes to the building, if you're using it at night or versus the day, it can be a big savings in energy. It depends where you go on what that energy is being created with, okay? Whether you're going to be saving carbon in that particular application. So it's something you have to look at on an individualized basis around the country, depending on what grid you're in. Another question. I know I saw it. Okay, well, thank you very much for your time. I appreciate it.